Hello. This morning we're going to go over 157 and 158. It looks like this. Let's do it. 157, 158, both very interesting questions. So 57 states a researcher conducted a 23-year-long study among 10,125 employees in a certain country. All were men over the age of 40. Eventually, 369 died of a stroke. Participants were surveyed at the beginning about their perceptions of family problems. Among the 9,000 who reported a happy life, 3.5% of those died of a stroke. Among those 1,125 who reported serious problems in their personal life, the death rate was 4.8. What's the p-value of the appropriate test to see if there is a relationship? So what they're giving us here is similar to the last problem. It's a two-way table question. They're asking, did you die of a stroke, yes or no? Okay. And they're also asking, so that's two categorical data. Two categorical questions. Did you have a happy life or not a happy life? Family problems of some sort. So let's make sure that everyone said yes or no to each one. It looks like eventually out of a total of 10,125, 369 of those died of a stroke, which would mean that 9,756 of them should not have died of a stroke. So we've got that covered. Now let's get to this happy life stuff. Among the 9,000 who reported a happy life, so it appears that 9,000 reported a happy life, which would leave us 1,125 that said, nope, I had some family problems. So that number's actually in my problem, so I feel pretty good. I just double check, add these two up. So I'm feeling pretty good that everybody did in the study say happy life or nope, I had some family problems. I'm just going to call that not a happy life. So now they're giving us some conditional probabilities. So it states of these 9,000, 3.5% died of stroke. So they gave us some math to do to fill in this box. So what is 3.5% of, and of means multiply, 9,000. So this is 3.5%, 9,000, I get 317 people. So 3.5% of 9,000 is 315 people. Then they give me a little bit more math. Among these people, the not so happy life peeps, 4.8% of those folks died of a stroke. So they've given us some math for this box. So 4.8% of these 1,125 people. When I crunch the math, I get 54. So I'm just going to double check my math. If I add these up, I get, yep, so these total the number of people that got a stroke. And now I can finish using the complement rule, filling out the table here, and just double checking my math, making sure these add up to 9,000. Making sure these add up to 1,125. Now, they've actually asked us to do a test for independence or a test for an association here. They're asking, is there an association between stroke and a happy life? Which I think is a good question. A lot of people want to know. So H sub O is there is no association. And H sub A is there is. So let's see what conclusion we would come to. And in order to be able to come to a conclusion, we need a p-value. So I'm liking this question because it's forcing us to actually type this in a calculator. So let's do it. First, we have to go to our menu. or excuse me, first we have to go to naming my matrix, and this is a two-way table, chi-squared test. So a chi-squared test, and I need to plug in a two-way table. Okay, so first I'm going to name the table though, so I'm just going to call it stroke, I guess, S-T-R-O-K-E. So I've named my matrix stroke, and then I want to hit control, so it gives me colon and equal sign. So control boxes, and then I want to hit boxes again. And I actually just have this 4 boxes to plug in. So usually if I have multiple boxes, I'm going to go here, but I'm going to actually stick with this one. And I literally plug these numbers in. 315, 54, 86, 85, 1071. And let the calculator do the rest. So I hit enter, and this confirms they got my information. And now I'm going to go to menu and do a stat test. And those are my 2 chi-square choices. And I definitely need to do a two-way table because I've got a two-way table. This is not a goodness of fit. So my observations, well, these were, of course, my observations, and I just called that stroke. There it is, stroke. Hit enter. And now, notice they gave me a p-value, so it does look like there's an association here, and I believe we knew that. If doctors do tell you to live a less stressful life, or else you're going to get a stroke. So it does look like there's an association between the two, because the calculated p-value was 0.028. And that is our answer, and that is what they asked us. Now let's go to the next question. This is an interesting question, because I got my Tampa Bay Rays t-shirt on today. What if I did a study in a baseball stadium parking lot? So a baseball stadium parking lot could literally have, 10,000 spots in it. Somebody wanted to do a study of what and calculate the proportion of people that own pickup trucks compared to all other vehicles. So your sample would be just your pickups, number of your pickup trucks, over your total vehicles. Now I'm already thinking this is a little bit weird, but we'll see how it goes here. It says he decides to take several random samples of 100. So that's okay. So his sample size is 100, and he's going to take a number, he's going to do it multiple times, which is cool. You can do studies multiple times. So no problems there. However, we're going to find which of the following is not correct. So we got to be really careful. That means we're going to have 4 correct statements, 1 not correct. So it says we're going to go to a parking lot of a baseball stadium, and we're going to use the numbers assigned to the stalls, assuming, let's just use for argument's sake, that all the stalls are numbered 1 to 10,000. Now, first and foremost, I feel like there's a problem here, and this one zeroes in on it. It says there may be some sample bias because baseball fans may not have the same preference of the general population, and I would totally agree with that. So this is definitely a true statement. But I'm not looking for which one's true. I'm looking for which one's false. So now I'm going to look for, well, what else did the question make me think about? Also, I feel like I'm worried about the issue of, we know at a baseball game, preferred seating is expensive. So E kind of zeroes in on this concept. It's improper to select the first 100 stalls closest to the gate, because that may be people that are likely to have high income levels. And that's totally true. So we've eliminated E and C because I'm actually looking for a statement that's not true. The next one states, if a particular numbered stall is selected at random, doesn't have a truck, it's acceptable to continue examining the stalls to the left until a truck is found. What? No. No. This one is definitely not true. It is not acceptable to do that. Again, if you're doing a random sample, and it says that you were doing random samples, then each of the 10,000 spots needed an equal chance of being chosen. If you randomly choose stalls 23, 28, 105, 9,006, 437, you get the point. I'm literally randomly picking 10,000 out of 10,000 spots, a group of 100, and he's basically saying if you pick stall 23 and you don't see a pickup truck, just look to the left of this stall 23 until you find one. That's not how you do a random sample. Not even close. So definitely D is out. Thanks for joining us.